Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good morning to everyone. So welcome back to another video. So in this video, we're going to learn about the molecular geometry, which is subtopic 4.2 in chapter 4 chemical bonding. Okay, for this video, I'm going to divide into two different parts. So the first part is I'm going to introduce you to the different shape of the molecule. And on the second part, I'm going to teach you how to explain in when you determine the molecular shape of the molecule. Okay, so by the end of this lesson, you should be able to explain the valence shell electron pair repulsion theory, or also known as Vesper theory. The second learning outcome is you should be able to draw the basic molecular shape from a given molecular formula. And the third one, you need to be able to predict and explain the shape of the molecule and also the bond angle in a given species. Okay, so we're going to start with the Vesper theory because you need some sort of rule, okay, on how to determine the molecular shape of the molecule from the Lewis structure. Because daripada Lewis structure, it is quite impossible for us to determine the actual shape. So remember that the molecule exists in space. So in space, that means it exists in the three-dimensional space. So the molecule can be either on the X, on the Y, or the Z axis. So we're going to take into consideration the existence of the molecule in space when drawing or when determining the molecular shape of the molecule. Okay, so Vesper theory state that in order to minimize the repulsion, okay, between the bonding pair and also the non-bonding pair, each group of the valence electron around the central atom will locate as far as possible from the others. Sebab apa? Sebab bonding pair and also non-bonding pair are made up of electrons. So when there are more than one electron that located near with each other, since electron have the same charge, which is a negative charge, so of course lah dia akan repel between each other. So Vesper theory ni state that in order to minimize the repulsion between the electron that made up the bonding and also the non-bonding pair around the central atom, both needed to be located as far as possible so that the repulsion can be reduced and the molecule will become stable. Okay, see, this is the Vesper theory. So you need to bear in mind when you draw the molecular shape, you need to remember the Vesper theory. And the Vesper theory state that in order to minimize the repulsion, okay, each of the electron group need to be located as far as possible from the others. Okay, so tadi saya cerita tentang pasal group of electron. Okay, what can we categorize as the group of electron? So a group of electron is any number that occupy a localized region around the atom, and for this case is around the central atom. Okay, and there are few different type of group of electron. Okay, a single bond. Okay, a single bond kita kira dia sebagai one electron group. Okay, so for example, for a molecule of HCl, okay, this single bond we consider as one electron group. Okay, a double bond. Okay, a double bond also we consider as a one group of electrons. So let's say for example for a double bond, kalau saya ada C double bond O, double bond O. So this is a Lewis structure for a carbon dioxide. Okay, even though there are the double bond, when you determine the molecular shape of the molecule, the double bond ini kita assume dia sebagai one electron group. So for a CO2 molecule, if we look at the Lewis structure, we have two double bond. That means CO2 dia akan ada two electron group sebab dia ada dua double bond. Sebab satu double bond, kita akan assume dia sebagai one electron group. Okay, and then we have a triple bond. A triple bond we also consider as one electron group. So for example, HCN. So if we draw the molecular if you draw the Lewis structure of HCN, so this is going to be H, single bond C, triple bond N. The triple bond we consider as one electron group. So the total number of electron groups surrounding the central atom, carbon in HCN, is equal to 2 electron group. A lone pair, okay, a lone pair we also consider as one electron group. So for example, for H2O, okay, this is the Lewis structure for H2O. So single bond kita kira sebagai satu. So we have one electron group, one electron group. Okay, this one pair of lone pair kita also consider this sebagai one electron group, and this one we also consider it sebagai one electron group. So the total number of electron group surrounding the water molecule or in the water molecule is equals to 4. Okay, one lone pair, one lone electron we also consider as one electron group. So contohnya kalau saya ada NO2, so if we draw the Lewis structure of NO2, so kita akan dapat satu lone electron on the central atom. So one lone electron ini kita akan consider sebagai one electron group. Okay, so double bond kita consider sebagai one electron group. Single bond we also consider this sebagai one electron group. So the total number of electron group in NO2 okay, is equals to 3. So awak kena tahu dulu macam mana nak determine number of electron group, baru awak boleh dapat tahu the molecular shape of the molecule. Okay, so now we already learned about the electron group and also the whisper theory. Now we can learn on how to classify or how to determine the molecular shape, okay, from the Lewis structure. Okay, so when you want to determine the molecular shape, you need to determine the electron group arrangement first. So that's why awal-awal tadi saya ajar macam mana nak determine electron group. Okay, because the arrangement of the electron group, okay, akan menentukan the molecular shape of the molecule. Okay, and the arrangement or the electron group arrangement, okay, kita kena include sekali bonding and also non-bonding group. Okay, bonding itu maknanya dia akan either single bond atau double bond atau triple bond. Okay, a non-bonding group. Okay, a non-bonding group ini adalah ataupun nama lain dia kita panggil sebagai lone pair electron ataupun lone electron. Okay, so ingat nak determine molecular shape of the molecule, awak kena kira sekali total number of bonding group and also non-bonding group. So non-bonding group tu kita ada dua, kita boleh jadi lone pair electron ataupun lone electron. Okay, if surrounding the central atom itu hanyalah bonding group sahaja, maknanya tak ada lone pair. So surrounding the central atom itu hanya ada bonding group without the lone pair, there are 5 basic molecular shape. So from the 5 basic molecular shape tu, dia akan terhasil lagi banyak molecular shape yang lain. So kita boleh derive daripada situ. Okay, these are the 5 molecular shape. Okay, when we only have bonding group surrounding the central atom. Okay, so the red circle, okay, the red circle is the central atom. Okay, and then the grey one, okay, and then grey itu adalah dia punya terminal atom. If around the central atom we only have 2 electron group dan kedua-dua itu adalah bonding electron dan tidak ada lone pair on the central atom. Okay, the shape we call it as a linear. So when you draw the molecular shape of the molecule, you need to know the name and you also need to know the bond angle between the atoms. Okay, for a linear, the bond angle is 180 degree. Okay, if you have 3 bonding group around the central atom, okay, the shape we call it as a trigonal planar. Okay, and the angle inside the trigonal planar is 120 degree. If you have 4 bonding group around the central atom, okay, the shape is going to be tetrahedral and it will have a bond angle of 109.5 degree. 5 bonding group, okay, 5 bonding group, we call it as trigonal bipyramidal. Okay, and you have 2 different angle. So we have 120 and 90 degree. So after this saya akan explain in great detail lah macam mana awak nak tahu dia punya angle itu. Okay, and the last one, if you have 6 bonding group around the central atom, okay, dan the central atom itu tidak ada lone pair, the molecular shape we call it as a octahedral. And octahedral we have a bond angle of 90 degree. Okay, so when you want to classify, okay, macam saya kata tadi, when you want to classify the molecular shape, we need to consider both the bonding pair and also the non-bonding pair. However, Bonding pair and non-bonding pair, the repulsion is different. Ataupun the strength of the repulsion dia akan berbeza. So, in order to determine the strength of the repulsion, okay, lone pair repulsion is stronger compared to lone pair bonding pair repulsion. And the bonding pair repulsion is stronger compared to, is the weakest one. Okay, so let's say kalau saya ada H2O, okay, Lewis structure for H2O. So H2O we have two lone pair on the central atom. Okay, so the repulsion between lone pair and lone pair ini is the strongest. Sebab apa? Sebab lone pair dia tak terikat dengan nukleus. So maknanya dia occupy more space, dia occupy a larger space around the central atom. So that's why lah, okay, lone pair repulsion is stronger. Okay, bonding pair and bonding pair repulsion is the weakest. Okay, sebab apa? Sebab electron dalam bonding pair is tightly held to the nucleus. So the mana dia only occupy a very small space. So that's why repulsion is the weakest. And lone pair and bonding pair repulsion, okay, is stronger compared to bonding pair but weaker compared to lone pair repulsion. So when you want to determine the molecular shape, awak kena consider the different strength of repulsion. Okay, so awak kena ingat lone pair repulsion is stronger than lone pair bonding pair repulsion. And the lone pair bonding pair repulsion is stronger than the bonding pair repulsion. Okay, so in order to make life easier, normally when we want to classify a molecular shape, we can assign each of the molecule with a different classes. Okay, we're going to assign with A, B, M, E, N designation. Okay, where A is the central atom, B is the terminal atom, M is the number of terminal atom, E is the lone pair, and also N is the number of the lone pair around the central atom. Okay, so the first, or the simplest molecular shape that can arise is when you have two electron group around the central atom. Okay, if you have two electron group, okay, around the central atom, dia tak, awak includekan sekali lah bonding pair dengan non-bonding pair. The electron group arrangement, we call it as a linear. So, electron group arrangement dia adalah linear. So, when dekat central atom tu tak ada lone pair, okay, if dekat central atom tak ada lone pair, the molecular geometry tu kita panggil dia sebagai linear molecular geometry. And the class of the molecule is AB2. Okay, A refer to the central atom and B refer to the terminal atom. Okay, B2 merujuk kepada number of terminal atom. So, kalau awak ada satu central atom, dua terminal atom dan tak ada lone pair on the central atom, the molecular geometry adalah linear dan electron group arrangement dia adalah linear. Okay, so the bond angle, between BAB for a linear molecule is 180 degree. So the bond angle between BAB is equal to 180 degree. So, okay, this is the molecular geometry, okay, untuk linear. So, let's say kalau yang biru ini, okay, biru ini adalah kita punya central atom dan yang putih ini adalah kita punya terminal atom. Okay, so kalau awak tengok dia straight line, sebab tu kita panggil sebagai linear dan angle for a straight line, the angle is 180 degree. So, angle from this atom, okay, to this atom adalah 180 darjah. Okay, so for a three electron group arrangement, okay, kalau awak ada three electron group arrangement, kita panggil dia sebagai trigonal planar. Okay, kalau kita ada satu central atom and three bonding group without any lone pair on the central atom, the molecular geometry itu kita panggil dia sebagai trigonal planar. Okay, trigonal planar, that means number of bonding pair dia 3, number of lone pair dia 0. And the bond angle between BAB adalah 120 degree. Okay, each BAB bond angle is equal to 120 degree. Okay, trigonal maknanya adalah 3. Okay, planar maknanya adalah flat. So kalau awak tengok molekular geometri ini, kalau awak tengok molekular geometri ini, kalau awak letak dia dekat tempat rata, awak akan tengok dia memang flat on the surface. Dan angle between this atom, this and this is 120 degree. Okay, sebab tu kita panggil dia sebagai trigonal planar. Sebab apa? Sebab trigonal sebab dia ada tiga bucu. Planar sebab dia adalah flat. Okay, however, kalau saya remove one of the bonding group from the trigonal planar, one of the bonding group from the trigonal planar, so sini awak assume lah ada lone pair electron. Sini awak assume ada lone pair electron. So, apabila wujudnya lone pair electron, kita kena ingat Vesper teori tadi. Lone pair bonding pair repulsion is stronger than the bonding pair repulsion. So maknanya tadi dia akan push, dia akan push the bond angle tu, dia menyebabkan bond angle tu reduce. So that's why lah kalau awak ada molecule with two bonding pair and one lone pair, electron good arrangement trigonal planar. Tapi sebabkan adanya lone pair itu, sebab lone pair repulsion tu is quite strong compared to bonding pair. So dia akan push sedikit bond angle between bonding pair itu. That's why lah bond angle dia akan lagi rendah daripada 120 degree. Dan if you have two bonding pair and one lone pair on the central atom, the shape we call it as a band, ataupun sometimes people call it as a V shape. Awak boleh tulis band boleh, ataupun awak boleh tulis shape dia sebagai V shape. Okay. Now, if you have 4 electron group arrangement, electron group maknanya kalau awak tambahkan number of bonding pair and number of non-bonding pair bersama dengan 4, electron group arrangement itu awak akan dapat sama dengan nama dia adalah tetrahedral. Tetra ini maksud dia 4. Hedral come from the word hadron. Maknanya face. Maknanya molecular geometry ni akan ada 4 permukaan. So kalau awak draw dia punya permukaan, awak akan dapat 1 sini, 2, 3, 4 yang dekat bawah. Awak akan dapat 4 permukaan. If you have 4 bonding pair around the central atom without lone pair, the shape or the molecular geometry we call it as a tetrahedral. Kita panggil dia sebagai tetrahedral. So kalau awak tengok molecular shape tetrahedral, satu akan pergi dekat atas, satu ini akan menghadap ke awak, satu ini akan macam straight, dan satu lagi akan opposite ataupun menghadap jauh daripada awak. So dan the angle, and the angle between each of the bond ini, angle dia adalah 109.5. So kalau saya remove one of the bonding pair, kalau saya remove one of the bonding pair from the tetrahedral, so sekarang ini number of bonding pair dia adalah 3. 1, 2, 3. Ini adalah number of bonding pair. Dan sini kita akan ada satu lone pair. So we know that based on the Vesper theory, lone pair bonding pair repulsion is stronger than bonding pair repulsion. So dia akan reduce the bond angle, dia akan reduce the bond angle dan dia akan menghasilkan satu lagi bentuk yang baru. Kita panggil dia sebagai trigonal pyramidal. Kita panggil sebagai trigonal pyramidal. Since the lone pair exists and we know that the lone pair will produce a greater repulsion, dia akan reduce angle tetrahedral tu. Sebab kalau the perfect tetrahedral, the bond angle is 109.5. Tapi sebab ada lone pair, bond angle dia akan will become less than 109.5. So now, let's say kalau saya masih ada 4 electron group arrangement, tapi saya remove lagi satu bonding pair. So maknanya awak akan ada 2 lone pair dan ada 2 bonding pair. So maknanya akan ada bertambahan lagi satu lone pair. So kalau awak tengok bentuk dia adalah kita boleh panggil sebagai band ataupun kita boleh panggil dia sebagai V shape. Dan angle dia akan lagi-lagi rendah daripada 109.5. So this angle between this is less than 109.5. Dan angle dia akan lagi rendah daripada angle dekat trigonal pyramidal. Sebab kalau awak tengok, trigonal pyramidal only have one lone pair. Okay, tapi for a V shape that derive from the tetrahedral, we're going to have two lone pair. So we have lone pair repulsion. Remember that based on Vesper, the lone pair repulsion is the greatest. So dia akan push, dia akan reducekan lagi bond angle between the atom dalam molekul tu. Sebab itulah dia punya bond angle tu akan jadi lagi sikit daripada 109.5. Okay, for a 5 electron group arrangement, okay, kalau awak ada 5 electron group arrangement, maknanya awak tambahkan bonding pair and also number of non-bonding pair, the electron group arrangement itu kita akan panggil dia sebagai trigonal bipyramidal. Okay, so the molecular geometry, kalau awak ada 5 bonding pair without any lone pair on the central atom, okay, so the shape itu kita akan panggil dia sebagai trigonal bipyramidal. Okay, number of bonding pair 5, number of lone pair 0. Okay, this molecule awak akan ada two different angle. Okay, so this is the molecular model for a trigonal bipyramidal. Yang awak nampak dekat atas, okay, dekat bawah ini, okay, awak atas dengan bawah, yang ini kita panggil dia sebagai axial. So the one that located at the top and the bottom of the plane, we call it as axial. Okay, the one yang flat ini, okay, yang flat ini, we call it as equatorial. Equatorial. Okay, so you are in a trigonal pyramidal, you go ahead to have 2 axial atom and 3 equatorial atom. So the bond angle, okay, bond angle between equatorial and equatorial is equals to 120 degree. Sebab kalau awak tengok, okay, kalau awak tengok dari sini, ni yang equatorial tadi. So awak tengok equatorial itu dia bentuk dia sama macam square planar. So kalau ni maknanya the angle between this central atom and this terminal atom is equal to 120 degree. However, the bond angle between axial and equatorial, so awak ingat axial yang atas dengan bawah. So the bond angle between axial and equatorial itu adalah 90 degree. So bond angle ni lah 90 degree. Okay, so when you want to remove bonding pair daripada trigonal bipyramidal, we only remove from the equatorial position. Sebab the greater the bond angle, okay, so the greater the bond angle, the weaker the repulsion. So that's why, sebab kalau based on Vesper, we need to minimize the repulsion between the electron group. So that's why lah, kalau awak nak remove bonding pair daripada trigonal bipyramidal, kita hanya akan remove daripada equatorial sahaja. Sebab kalau awak tengok, the bond angle between equatorial atom akan lagi tinggi daripada bond angle dekat axial. Okay. So the greater the bond angle, the weaker the repulsion. Sebab kalau bond angle bertambah, maknanya jarak dia pun akan makin lama makin besar. So kalau jarak electron tu makin lama makin jauh, so repulsion pun akan makin lama makin kurang. So that's why awak kena ingat, kalau awak nak remove bonding pair daripada trigonal bipyramidal, awak hanya remove daripada equatorial position sahaja. Okay. So let's say if I remove one bonding pair from the equatorial position, okay, kalau saya remove one bonding pair, okay, dia akan produce satu molecular shape yang kita panggil sebagai seesaw ataupun distorted tetrahedral. Ini kita panggil seesaw. Okay, sebab dah ada lone pair dekat sini dan lone pair itu akan push bond angle tu, dia akan reduce bond angle. So that's why lah bond angle between equatorial and equatorial akan lagi rendah daripada 120 degree, and the bond angle between axial and equatorial will be reduced to become less than 90 degree. Sebab apa? Once ada lone pair repulsion ni lagi kuat daripada bond pair repulsion. So dia akan push. Okay, yang ini kita panggil dia sebagai distorted tetrahedral ataupun seesaw. Now, if I remove another Okay, another bonding pair. Okay, so maknanya sekarang ini asal electron group arrangement dia masih trigonal bipyramidal sebab ada total dia ada 5. Okay, tapi ada 2 lone pair. Okay, dan ada 3 bonding pair. So bentuk yang akan terhasil kita panggil sebagai T-shape. So kalau awak tengok, ini macam bentuk T. Ini macam bentuk T. So T-shape, number of bonding pair dia 3, number of lone pair dia is 2. So T-shape, since awak dah ada 2 lone pair electron sini, so lone pair electron ini akan reduce the bond angle. So kalau awak tengok, awak remember that the bond angle between axial and equatorial kalau dalam perfect trigonal bipyramidal adalah exactly 90 degree. Tapi since there's 2 lone pair on the central atom, ingat lone pair itu dia akan tolak, dia akan reduce bond angle tu yang menyebabkan bond angle ni akan jadi less than 90 degree. Okay. So, kalau saya remove lagi satu bonding pair daripada central atom, awak tengok dia akan jadi bentuk linear. So, maknanya linear itu akan terhasil apabila awak ada 2 bonding pair dan 3 lone pair. Okay, so kalau linear, the bond angle of linear must equals to 180 degree. Okay, so the last one is the 6 electron group arrangement. Okay, 6 electron group arrangement, we call it as the octahedral. Okay, when you have 6 bonding pair around the central atom without any lone pair, the molecular geometry we call it as a octahedral. So, and the bond angle between the atom is exactly 90 degree. So, this is example ataupun molecular model of octahedral. So, kalau awak tengok, bond angle untuk setiap satu itu semua adalah 90 degree. So, semua adalah 90 degree. Now, same goes macam trigonal bipyramidal. In order to minimize the repulsion, we need so kita akan remove bonding pair itu. So kita akan wujudkan satu lone pair. Okay. So kalau saya remove satu bonding pair, so now the total bonding pair adalah 5 dan number of lone pair dia 1 ke bawah ni. So number of lone pair ini dia akan reduce bond angle itu. So dia akan reduce bond angle itu daripada 90 degree dia akan jadi less than 90 degree. Okay, so dia akan jadikan less than 90 degree. So, if I remove another bonding pair, okay, kita akan hasilkan satu bentuk ini, yang bentuk macam X ini. Yang ini we call it as a square planar. It's when you have electron group arrangement octahedral, tapi number of bonding pair dia 4, number of lone pair dia 2. Okay, itu kita panggil sebagai square planar. So, in order to minimize the repulsion, okay, square planar tu makna flat. In order to minimize the repulsion, the 2 lone pair itu mesti terletak dekat atas dan bawah. Sebab kalau 2 lone pair itu terletak berada antara satu sama lain, berada bersebelahan, repulsion akan kuat. So remember that based on Vesper, kita kena minimize repulsion tu. So that in order to minimize the repulsion, so kita akan letak satu lone pair dekat atas dan kita akan letak satu lone pair dekat bawah. Dan shape dia adalah square planar. Okay, I think that's all for this video, and we're going to make in the next video, which is molecular geometry part 2. Okay, so thank you everyone.